Electrical grounding and its effects on pipe integrity and shock hazards are complex issues. A comprehensive study examined these effects, and several key findings emerged. Firstly, alternating current, or AC, causes minimal corrosion, approximately 1% of that caused by direct current, or DC. Secondly, direct current, or DC, can flow towards or away from a house. If DC current flows away from the house, it can cause significant corrosion of metal pipes. Sources of DC current include appliances like dryers and electric drills. The extent of corrosion is influenced by several corrosion factors. Soil resistivity (pH) and the presence of chemicals in the soil significantly impact the extent of corrosion. Several prevention measures can be implemented. Non-metallic water service lines prevent current flow and corrosion. Insulating jumpers at the water meter can block electric current. Regarding risks and mitigation, electric shock is a significant concern. Approximately 1 water meter repair person receives a serious electric shock in the United States per day. Open neutrals are a major cause of these electric shocks. Insulating jumpers at the water meter can mitigate this risk. However, there are limitations to these measures. Some utilities cannot use insulating jumpers due to the use of electric pipe thawing methods in winter. The study involved examining over 100 homes and measuring AC and DC current on water pipes. The report detailing these findings is extensive, spanning 215 pages, and is well written. Although the report is no longer in print, it remains a valuable resource for understanding the effects of electrical grounding on water pipes. To elaborate further on the topic of corrosion, it's important to understand the electrochemical processes involved. When DC current flows from a metal pipe into the surrounding soil, it causes the metal to oxidize, releasing metal ions into the soil. This is the process of corrosion. The rate of corrosion is directly proportional to the amount of DC current flowing and is influenced by the soil's characteristics. High soil resistivity reduces the flow of current and therefore reduces corrosion, while low soil resistivity increases the current flow and accelerates corrosion. The pH of the soil also plays a crucial role. Acidic soils with low pH values tend to be more corrosive than alkaline soils with high pH values. This is because acidic environments promote the dissolution of metal ions. The presence of certain chemicals in the soil, such as chlorides and sulfates, can also accelerate corrosion. These chemicals act as electrolytes, increasing the conductivity of the soil and facilitating the flow of current. In contrast, other chemicals, such as phosphates, can inhibit corrosion by forming protective layers on the metal surface. The type of metal used for the water pipes also affects the rate of corrosion. Some metals, such as copper and stainless steel, are more resistant to corrosion than others, such as iron and steel. However, even corrosion-resistant metals can corrode under certain conditions. Regarding the use of insulating jumpers, it's essential to understand how they work and why they are effective in preventing electric shock. An insulating jumper is a non-conductive fitting installed at the water meter, which interrupts the electrical path between the customer's plumbing system and the utility's water distribution system. This prevents current from flowing through the water pipes, reducing the risk of electric shock to anyone who comes into contact with the pipes. The effectiveness of insulating jumpers depends on their ability to completely block the flow of current. Therefore, it's crucial to ensure that the jumpers are properly installed and maintained. Any damage or deterioration of the jumper can compromise its insulating properties and increase the risk of electric shock. In addition to preventing electric shock, insulating jumpers can also help to reduce corrosion by preventing stray currents from flowing through the water pipes. However, as noted earlier, some utilities cannot use insulating jumpers because they use electric pipe thawing methods in winter. Electric pipe thawing involves passing a large current through frozen water pipes to thaw them. This method is effective but also poses a risk of electric shock if the pipes are not properly insulated. Therefore, utilities that use electric pipe thawing must take extra precautions to ensure the safety of their personnel and the public. These precautions may include using insulated connectors, grounding the pipes, and providing training to workers on how to safely perform electric pipe thawing. Another important aspect of electrical grounding is the role of the neutral conductor. In a typical electrical system, the neutral conductor provides a return path for current. If the neutral conductor becomes open or disconnected, it can cause voltage to rise on other circuits, creating a shock hazard. This is why it's essential to ensure that the neutral conductor is properly connected and maintained. Open neutrals can occur for a variety of reasons, including loose connections, corrosion, and physical damage. Therefore, it's crucial to periodically inspect electrical systems for signs of open neutrals and to take corrective action as needed. In addition to the measures discussed above, there are other steps that can be taken to reduce the risk of electric shock and corrosion. These include using ground fault circuit interrupters, or GFCIs, which can detect small amounts of current leakage and quickly shut off the power, and using corrosion-resistant materials for water pipes and fittings. It's also important to educate the public about the risks of electric shock and corrosion and to encourage them to take precautions, such as avoiding contact with water pipes during electrical storms and reporting any signs of corrosion or electrical problems to the appropriate authorities. The study's findings highlight the importance of a comprehensive approach to electrical grounding, taking into account both safety and corrosion concerns. By understanding the factors that contribute to electric shock and corrosion, and by implementing appropriate prevention measures, it's possible to reduce the risks and ensure the safety and reliability of water distribution systems. Furthermore, the American Water Works Association, or AWA, has other resources and guidelines available for water utilities to help them manage electrical grounding issues. These resources cover a wide range of topics, including the design and installation of grounding systems, the testing and maintenance of grounding systems, and the investigation of electrical problems. By utilizing these resources, water utilities can improve their understanding of electrical grounding and implement best practices to protect their personnel and the public. In conclusion, the effects of electrical grounding on water pipe integrity and shock hazards are complex and multifaceted. However, by understanding the key factors involved and by implementing appropriate prevention measures, it's possible to mitigate the risks and ensure the safety and reliability of water distribution systems. This requires a collaborative effort involving water utilities, electrical contractors, and the public. By working together, we can create a safer and more sustainable water infrastructure. Also, it is important to understand that the information presented here is based on a specific study and may not be applicable to all situations. Electrical grounding practices and regulations vary depending on the location and the specific characteristics of the water distribution system. Therefore, it's essential to consult with qualified professionals and to follow all applicable codes and regulations. The study also highlights the importance of ongoing research and development in the field of electrical grounding. As new technologies and materials emerge, it's crucial to evaluate their potential impact on water pipe integrity and shock hazards and to update grounding practices accordingly. This will help to ensure that water distribution systems remain safe and reliable for years to come.